Hey, chemistry. I would like you to get ready for lab number 14.1. We are going to compare chemical reaction rates. What I want you to do is write on your lab paper. You can print it from what I uploaded. It's a PDF online on the HSA website, or you can just grab a clean sheet of notebook paper, whichever works for you. I'm not super picky. Don't worry about it as long as you're learning. I really don't care. All right, here's the deal. We're going to follow it along in the book. You can look in your book. You can do it at home. You can watch us do it here at my house, whatever you need to do, okay? Understand what's happening. Here we go. You're going to write down your name. You're going to write down your class number, chemistry 915 or chemistry 1015. You are going to write down the name of the experiment. You're going to write down experiment 14.1 so that we can always find it later if we want to. You're going to write down the supplies needed. That would be hydrochloric acid in the form of the Works toilet bowl cleaner. You're going to need an antacid tablet. You're going to need 4 different glass containers. And the book says test tubes, but I don't keep those around my house. I have jelly jars, so that's what we're using today. I've labeled each of my jelly jars, as you will see, and we're going to do our experiment within them. Here's the deal. We are going to have 3 separate hypotheses. Are you ready? One is going to be test tube 1 versus test tube number 2. You writing this down? 1 versus 2. Go ahead and pause it if you need to. Hypothesis number 1 is test tube 1 versus test tube number 2. We are going to change the surface area. And the question is, how is that, if we increase surface area, how will that change the chemical reaction rate? Will it increase it, keep it the same, or decrease it? Okay, super easy, simple question. Well, maybe you'll be surprised, but we'll see what happens. All right, hypothesis number 2 is test tube 1 versus test tube 3. We are going to change the temperature. You can make the delta, the triangle is the delta, so delta temp. All right, here's the hypothesis question. If we increase our temperature, how will that affect our chemical reaction rate? Will it increase our rate, keep it the same, or make it slower? You ready for number 3? You ready? You ready? Test tube number 1 versus test tube number 4. We are going to change the dilution, so delta dilution, okay? Here's the question. By changing the dilution, well, can't say that, we're gonna make it more specific. By increasing the dilution of our chemicals, okay, are we increasing or decreasing the rate of reaction? Okay, I'm gonna review them for you. Make sure you have them written down properly. Did you pause it? You should have paused it. Pause it now, write them down. Go back a few seconds if you need to. Here we go. Hypothesis question number 1, 1 versus 2, change in surface area. If we increase surface area, how does that affect our chemical reaction rate? Increase, stay the same, decrease. Hypothesis number 2, test tube 1 versus test tube 3, change in temp. If we increase the temperature, how is that going to affect our chemical reaction rate? Will it increase the rate, keep it the same, or make it reduced? Decrease. Okay, hypothesis number 3 is test tube number 1 versus test tube number 4. We have delta dilution. If we increase the dilution, how does that affect our reaction rate? Has it increased it, stayed the same, or decreased it? Okay, you got 3 hypotheses. Every single one is either going to be increased, stayed the same, or decrease, all right? We are going to do the experiment. Those videos are going to come next, and at the end, I'm probably not going to talk to you, but here's what I want you to do. I'm not going to talk to you. Here's what we're going to do. You are going to write 3 conclusions. Conclusion 1 is going to be, are you ready? 1 versus 2. By changing the surface area, did we increase or decrease? And you say, yep, I was right. Nope, I was wrong. Okay? Same thing. Conclusion number 2, test tube 1 versus test tube 3. By changing temperature, we increased, stayed the same, or decreased our chemical reaction rate. Tell me, were you right? Were you wrong? Conclusion number 3, test tube 1 versus test tube 4. We have increased the dilution. Did it increase? Did it decrease our reaction rate? And then tell me if you were right or wrong. Okay? I don't care if you're right or wrong. I just need to know that you understand that you were right or wrong and that you know what the right answer is. All right? Think you can handle it. You guys, seriously, email me, text me, whatever, if you have a question, if you don't understand what I'm asking. It's tough because I can't actually see you, because sometimes I can see you and you guys are like, whoa, what? And sometimes you're like, yeah, hurry up. Just going to breeze right through it. And if you have a question, please contact me. Okay? When you're done with your lab report, I want you to snap a picture. I want you to scan it. I want you to do whatever you need to do to get it back to me so that I can grade it. Understood? Excellent. Okay, here we go. All right, chemistry, experiment 14.1, observing factors that affect chemical reaction rates. I have, well, let me do it this way. I have 4 jelly jars. They look a little different. They have different glass. They're different brands. That's okay. You guys can follow along in your book. You should read the experiment. I'm not going to go through it step by step, but you can certainly observe what I am doing here at home. And certainly, if you got the stuff, go ahead and do it at home. It might be fun just to check it out yourself. I have labeled my test tubes. Number 1, which is going to be 4 teaspoons of, numbers 1, 2, and 3 are going to have 4 teaspoons of toilet bowl cleaner. They are each going to have a quarter of a tablet of antacid. Okay, this is kind of our control. 4 teaspoons and 1/4. Boom, all set. Number 2 is going to have the same amount of toilet bowl cleaner, but we're going to change things up a little. And I've already powdered this. This is 1/4 antacid. Definitely gonna have to put down my phone to get that in there. It has a greater surface area because it's been powdered. Okay. Number 3 is hot. I think I'm gonna need some hot pads to pull that out of there. Same thing as number 1, test tube number 1, except this is going to be hot toilet bowl cleaner. All right. Again, we're going to put a 1/4 tablet in there in the hot. And then number 4, actually, instead of 4 teaspoons of toilet bowl cleaner, I did 1 teaspoon of toilet bowl cleaner and 3 teaspoons of tap water. So same volume as far as liquid, but less hydrochloric acid in there, less of the toilet bowl cleaner, and again, a quarter of a tablet. So each of these has a 1/4 tablet in it. Each of these has 4 teaspoons of liquid in it. Number 1, 2, and 3 have 4 teaspoons of straight toilet bowl cleaner. Number 4 has 1 teaspoon of toilet bowl cleaner, 3 teaspoons of water. Each of them has a 1/4 tablet of antacid. Number 2 has been powdered to increase the surface area. We are going to let these sit for a few minutes, maybe stir them and swirl them a little bit to try to help them dissolve, and then we'll come back and see what the differences are between different factors. For example, diluting your acid, making your acid warm, or powdering one of your chemicals, okay? So, meet me back in just a few minutes. All right, set my timer for 5 minutes, and let's take a look. So we've gone through, what's that, like 1.5 minutes? So let's see what we got here. All righty. So we have our number 1. We're going to call that control. Okay, we still have a fair, I've swirled it a little bit here, okay? Doesn't look like it's done too much. This is our powdered one. Number 2 has our powdered antacid. It's kind of foamier than the other ones, actually. And stuff is dissolving. Number 3, that's our warm one, if you remember. Oh, lost my focus there. Okay, so if I swirl this a little bit, yeah, it looks a little bit smaller. This was our diluted one, and to be honest, I really don't see a lot happening there. That's okay. That's probably what the point of the experiment is. So, where'd he go? There it is. Here's our chunk here. It's not even all the way submerged. This one, I don't know. You're not going to see much in there because it was powdered. And how about this one here? It's got a few little bubbles on it, but not too much. Alrighty. We'll check it out again in a few minutes. We'll probably just go to the 5-minute mark. I'm going to continue to swirl these as we go, and I'll meet you back here in a few. All right, that was our 5 minutes. Now, what we have is our number 1, which is, we'll call it control, because we know how much toilet bowl cleaner was in there and how much antacid was in there. We're going to compare it to number 2. Okay, that's the first thing we're going to do is our control test tube 1 versus our experiment number 2. Now, what is the difference? They both have the same amount of toilet bowl cleaner in them. Everything sat for the same amount of 5 minutes. The difference is this was a solid chunk of antacid and this was powdered. So let's take a look inside. Okay, so what we have here, you can see there is still a good sized chunk of antacid in there. And then we're going to look over here in this one where the powdered stuff was. And we see, I don't know if you can see it real well, there's a little bit of residue in there. But
test tubes.
No, these are great test tubes. There is some residue in here, but not very much. So I would say that powdered chemicals increase the rate of chemical reactions. Okay, if one is powdered, it's more easily dissolved into the liquid. Okay, that's what I've learned from this experiment, 1 versus 2. Let's take number 2 out of the equation and let's look at number 3. All right, and if you remember, number 3 was hot. We have the same amount of liquid, the same amount of hydrochloric acid, the same amount of toilet bowl cleaner, and we added to each of them a solid 1/4 chunk of antacid. Remember, they look a little different. It's the size, it's the glass, it's whatever, okay? Let's look inside of them and see how much is left. So this is number 1. You just saw this a moment ago. You see there's a good sized chunk of antacid. It's smaller than it started, but it's still pretty much there. Now, if you remember, this was the warm toilet bowl cleaner. I put this on the stovetop in some warm water and heated it right up. So what do you see? We have changed what? We didn't change our antacid like we did in number 2. We've changed the temperature of our chemical reaction. And what do we see? When we have increased the temperature of our chemical reaction, the reaction rate increased. Okay, that's what we saw.
Powdered and hot.
Well, thank you for jumping ahead, Zeke.
Oh, I was supposed to not do that.
No, you're fine. Just keep your mouth closed. All right, so let's move on to number 3, our third. Well, number 4, our third comparison. So again, toilet bowl cleaner, antacid. We have the same amount of antacid in here. The difference we had here is less of our toilet bowl cleaner. Okay. So what we have is our 100%. We'll call it 100% concentration of toilet bowl cleaner, and then a 1/4 concentration of toilet bowl cleaner. And I'm sure you can make a guess, or I'm sure you can make a hypothesis here. Let's look in here. So we have a good sized chunk still left, and actually still some bubbles. And this one also has a good sized chunk, like hardly any bubbles. Okay, the bubbles are the carbon dioxide from, and that's actually our chemical. No, that's just from me shaking it. Okay, so I would say, like, not much happened, and that is because of the chemical dilution here in test tube number 4, because it was diluted. So if we dilute something, one of our chemicals, it slows down the rate of reaction. If we increase temperature of one of our chemicals, it will increase the rate of reaction. And if we increase the surface area of one of our chemicals, okay, the antacid tablet was powdered, so it had more surface area to react with things, it will increase. So increasing surface area increases your rate of reaction. Increasing temperature increases your rate of reaction. And reducing dilution will reduce your rate of reaction. So number 1 was our control, and these were our 3 experiments. This was actually like a 3-in-1 kind of experiment. Okay, so we're going to take you over to the book. We're going to look at the math, okay? Here we go. This is my book, you guys. I have a 1st edition book. You guys, probably most of you have the 3rd edition, so we might have things a little bit different, but I tell you what, this equation's the same, and chances are it's written right in your book. Just go ahead and look at it. This is inside of the experiment, okay, if you want to follow along there. I'm going to read it to you. 2 hydrochloric acid plus the calcium carbonate, which is the antacid tablet, becomes H2O, calcium chloride, calcium dichloride, see the number 2, and carbon dioxide. Okay, carbon dioxide is a gas. Got it? So when we dropped in the antacid tablets and we saw bubbles coming up, that was our CO2, that was our gas, okay? So that is the chemical reaction that we saw. The 2 ingredients that we combined, the 2 chemicals we combined, reacted with each other, did some chemical kind of nonsense, and became all these things, all right? That's what chemistry is. It's super cool. It's changing stuff around. Now, here's something I want you to know. Right down here, number 1, remember I kept going back to number 1? You probably can't see that. There we go. Control. I kept calling number 1 our control because that was the one that we didn't change things. We compared number 2 to number 1. We compared number 3 to number 1. We compared number 4 to number 1. Between 1 and 2, we changed only surface area. Everything else was the same. Between 1 and 3, we changed the heat, the temperature. Everything else was the same. Between 1 and 4, we changed the dilution or the amount of chemical in there. Everything else was the same. Nothing changed with this one. Every single one we compared to our control. I'm hoping you guys already know that, but if you didn't, there you go. I did tell you to make sure you read your bold sentences in your textbook, okay? Make sure you do that. That's going to help you answer questions at the end of your textbook.